real. Okay, we're going to solve trig functions on a restricted domain though, because trig functions go on forever, right? Like the sine curve goes beyond 2 pi, it goes on forever. So we're going to restrict our domain from 0 to 2 pi with a closed bracket on 0 and open on 2 pi. Okay, so to solve our first trig function, I have 2 cosine of x equals -1. What does sum actually mean? Find the value of x. Okay, so how would you go about doing that? Divide by 2. Okay, so we get cosine x equals -1/2. Now, to get this algebraically, let's see, how do you get rid of the x? Well, this is not cosine times x, this is cosine of x. Inverse cosine, right? So if we're going to do this algebraically, we'll do cosine -1 on both sides. Which, we'll just give us the x and we have cosine -1/2. Does anyone know what the inverse cosine of 1/2 is? -1/2. -1/2. Excuse me. I think it's actually easier to look right here in the blue. We do know which angle has a cosine equal to -1/2. So if you go back to cosine equal, remember cosine is x, x or y. So x, and the cosine has to be negative, so it tells you second or third quadrant. Which one has a cosine equal to -1/2? Let's do idiots, what are idiots in calculus? 2 pi thirds, that's the only one though, with an interval from 0 to 2 pi. 4 pi thirds and 2 pi thirds. So we have 2 that we need to respond because we have a third domain, it's not just one of them. So our x here equals 2 pi thirds and 4 pi thirds. Okay? So even though the inverse cosine, but I think it's a little different. I just think, okay, what angle cosine equals -1/2? Okay, what about this? Root 2 times secant of x, which equals 1. So if you solve for x, what's the first thing we do? Divide by root 2. Now, secant of x is not on a unit circle. When we do something that's not a unit circle, it's related to secant. Cosine, they are, what's that word? That's what you are. They sit codes of each other. So, secant of x, on that trig identity page, that gold paper gave you, what's secant of x equal to? 1 over the cosine of x equals 1 over root 2. So we can find cosine. So cosine of x would equal what? So we'll just do a little cross multiplication. I know some math teachers cringe at that, but it does work. Cosine of x equals root 2. Take our unit circle. Let's see what we got. Cosine of x, or what? Theta equals root 2 at the cosine spot, or the x. Can you figure that out, please? Can you figure that out, please? We got it. All our cosines and sines have something, I guess, the ones at 0, 90, 180 and 270. They all are fractions and all rationals, right? Let's go back to our solution. No solution. Okay, number 3. Cotangent of theta equals 0. So we don't have cotangent of the circle. And what's related to cotangent? 1 over tangent. Mix it up. Yeah, they'll come. Okay. 1 over tangent. So, what do you think? Somehow it's fewer. Solve for x. We're solving for theta, which is in the spot of x. Theta and x are interchangeable. Theta tells us for sure we're in radians. Yeah. Yeah. So good point. It will also change. Yeah, x is the same position as what theta would be. Okay, so they'll have cotangent or tangent actually, then on that unit circle. Do you know where the tangent appears in the unit circle? Yeah. The opposite side is measuring what? The y. And the adjacent side is measuring x and y over x. Or if the y is over the run. Right? And measure the slope of all of these the angle arms. It's the slope of all of them. So here, rise over run, 0 divided by 1. That tangent would be tangent of 0 degrees, 0 over 1. 0, then the slope is flat. Come on, 90 degrees. Straight up and down. Rise over run, 1 divided by 0. Tangent of 90 degrees. 1 divided by 0 is good. Now shall not divided by 0. Does it make sense? So straight up with the undefined slope? Yes. So straight up and run that for a few years. Right? That's why I'm going back degrees with my force. What kind of slope is that? 1. So 2 over 2 divided by 2 over 2 is 1. So rise the y divided by run the x. So the inverse of that, the cotangent, would be instead of, because tangent is y over x, so cotangent would be x over y equals 0. When does that happen? That the x divided by the y equals 0. That has to be, we just went over one of these, that has to be in the numerator to equal 0. 0. Can 0 be in the denominator to equal 0? No, that's undefined. Okay, so look for when we have a slope of 0. Actually, the tangent is the slope of 0, so cotangent would be the complete inverse of that. What's the opposite of 0? The inverse of it would be undefined. So which has a slope that's undefined? So negative is pi halves and 3 pi halves. That's the answer there, is pi halves and 3 pi halves. beta equals instead of x equals. So this, because I flip-flop this, I should have flip-flopped this right here as well. I should put 1 over 0. So our denominator is okay. Oh, you guys have a 4? My approach doesn't, but 4 and 5, but okay. I don't know, we can write it in. Number 4, we're going to keep solving, but we're going to use those trig identities. Sine x times tangent squared of x minus sine x equals 0. Sine x times tangent squared of x minus sine x equals 0. Okay? X's are all over the place. What type of function is this? It looks scary because there's trig functions in it. But what type of function does it look? Oh, it's summation. Okay. Okay. Do I have anything in common? I think that's kind of a longer way. These two do have anything in common. They both have sine x, so I'm not too just straight without one. Factor! That's what in common, let's pull it out. So we get tangent squared x, so we're going to factor out the sine x. And then have tangent squared x minus what? Minus 1. Okay? This is like solving quadratics. We can now apply the 0 property. When we're not solving quadratics, we get 2 factors. So we have here sine x equaling 0, and then tangent squared x minus 1 equaling 0, the 0 property. So where does sine x equals 0? So we're making a circle. Sine is that the x or the y coordinate? So find whether the y is 0. 0 to 2 pi, but not including 2 pi. Okay, look at the first one. 0 pi, then pi. Okay, we can't include 2 pi. Do you know why? Look at the original restricted domain. Have a bracket of 2 pi? No, parentheses. So we did not include 2 pi. So here x equals 0 and pi. We're going to have some more from the tangent. We solve out the tangent, we can go plus 1 plus 1. Tangent squared x equals 1. How do we fix the squared issue? No, it's tangent, we can totally do that. Tangent of x equals the square root of 1, which is just 1. If we apply the square root ourselves, you have to be very careful. We apply the square root wasn't originally there, we applied it ourselves. Times the square roots. Plus or minus. If it's already there, then you already know it's a positive root or a negative root that will give you. But if you apply it yourself, you have to do plus and minus, so it could be plus or minus 1. So tangent, remember, represents the slope. So we're going to have a positive 1 slope and a negative 1 slope. The closed interval 0 to the open interval 2 pi. So we're going to have a positive 1 slope in the first quadrant. Pi plus, because root 2 over root 2 is 1. Anything else? To the circle? Which one? Pi plus is also positive slope of 1, right? Positive slope of 1, all the way through that. Okay, anyone else? What? Positive 4 negative. Yeah, it can be positive or negative. We want to know the positives. What? 3 pi fourths. All the way through to what's the mountain one? 7 pi fourths. Okay, so we have lots of answers. X equals 0, pi, I'm show you all of them. Yeah, really got 4 that come out of 4 pi fourths, 5 pi fourths, 3 pi fourths, and 7 pi fourths. Okay, so make sure you're aware of what the domain is. If there's a domain, and then you can use a circle tangent is y over line, or the y divided by the x coordinate. And then answer questions. If there are questions here, it was everything in green. Everything goes. So no like simple worksheets. They're all together. So hopefully we're not confused. This is your homework. Make sure it says on the front unit circle, no calculators. You must use an exact answer. So root 2 over 2 is an exact answer. You have to have typing your calculator around the decimal. Use the exact answer. Root 2 over 2 is an exact answer. Then find all solutions. All solutions. So not just from 0 to 2 pi. All solutions. Okay? Yeah. Questions on the stage you play. Okay, so, speaking of questions, on the last assignment we have solutions, I think. What questions do you have on solving exponential and log worksheets? Yeah, they were green. I have to do this really fast. I might have to borrow this real quick. Fourteen. Solve each round answers to nearest 100. I should change the structure for the practice when I was going to go for decimal places. But if the direction can say something specific, we should okay, solve. So, some problems right here, they have excess trapped in the numerators or in the exponents. Right? So our trick was to make the bases the same. If the base is the same, the exponents are the same. Equal. The base is equal, the exponents are equal. So I think we can get a 3 out of the 27, can we? 3 times to the power. But since the 27 is in the denominator, we have to go 3 to the negative third power. All raised to 3x equals 3 to the 2x minus 1. So the power to the power, we do with the negative 3 and the 3x. Times. So we have negative 9x equals 2x minus 1. At this point, we can just set the exponents equal. Okay, can you solve it? Can you do the rest of that? So we do the same. So I don't have to do it right now. 6. Log base 2 on 4 to the 32 over 2. So let's evaluate. Okay? So, we just started thinking about ways. Can we break down the 4 to the 32? You can do that now or later. Okay, let's just do it later. I'm going to put equal to x, change it to exponential. 2 to the x equals 4 to the 32 over 2. That might have made my life a little worse, actually. Okay, now what's 4 to the 32 break down to? Is that just 2? Okay, then that didn't actually make it worse. So you get 2 over 2, which is 1. So 2 to the x equals 1. 2 to what exponent will equal 1? 0. Right? Anything to 0 power except for 0 itself. Yeah, that looks scary. 19. Again, we don't have to do it, it's not my worksheet. The 4 is a log of 19. Log x equals 2. Ooh, that looks fun. Directions. solve and round to the hundredths if necessary. Okay, let's see here. This is at what base? 10, so I'm going to try this. 10 squared equals log of x. What's 10 squared? 100 equals log of x. And I might go back. I was in the base. There's now an exponential. What's this base? 10. So base raised to this guy, 10 to the 100 equals what? X. A zero? Oh, I don't know. Maybe. Yeah, I'm not getting one of this number, so we'll just write this. This is the exact value, even though it's not like simplified. Okay, so green, I guess I can do 2 greens. I need to keep track of my colors better. This one on logs exponentials due next time. I'll have questions on unit table on trade next time. Yeah. Oh, so the bases are different, so that's an issue, right?